Welcome, everyone. I'm Harel Bourne, CEO of Swarm One, and thank you for joining us. This is a live webinar, and therefore, you're invited to write any questions you like in the chat. At the Q&A session at the end, we will do our very best to answer as many of them as possible. As opposed to many high-altitude flights on the subject, our talk today is not a theoretical AI infrastructure talk. It's about why brilliant AI teams fail to deliver impact and what can actually be done to fix that dire state of affairs. By the end of today, hopefully, you'll have a clear picture of what's holding AI teams back and the practical strategies, the real ways, the actual methods to move from experimentation to making real impact. To make use of the cutting edge technologies and tools that are already out there and are already available to all. Joining me today are three incredible experts whose names I'm sure you know without any presentation, and therefore I will present them nevertheless. First, Mr. Steve Nouri, the global AI leader who for years and years brings us insights on how AI teams think, communicate, operate, and improve themselves from ideation to production. Mr. Andriy Burkov, the renowned AI expert, author of the 100-page machine learning book and the language models book that many of us enjoyed, and me myself for several times, and another leading voice in AI architecture and deep learning systems. And last but certainly not least, Mr. Roman Vainshtein, leader of the global team of experts and researchers at Fujitsu Research in the Gen AI security and trust domain, who takes a central role in researching, determining, and building AI infrastructure for large enterprise adoption. Without further ado, let's dive in with the first subject. I see this pattern constantly across the industry. Teams build brilliant prototypes that wow leadership in demos. Then, 6, 8 months later, nothing is in production. The demo runs perfectly on a laptop with clean data, but production means distributed systems, real-world data pipelines, security reviews, and compliance checks, and whatnot. Andriy, let's start with you. From your hands-on perspective, what makes most prototypes architectural dead ends that can't evolve into production systems?
Well, most of the time, in my experience, it's a disconnect between what the data scientists think the problem they are solving and what the IT team thinks they can put in production. Because one thing is to run something on your laptop or in some notebook and see some quick and dirty result. And another thing is to make it scalable to thousands, sometimes hundreds of thousands of users, all working in parallel and all expecting 99.9% availability. So data scientists might engineer and often over-engineer a perfect solution, and then it's just impossible to practically to use it. And one famous example, maybe everyone knows, it's this famous Netflix prize that was Netflix organized a decade ago, where they offered a $1 million prize to the team who will improve their recommendation engine performance on Netflix at the time. And the winning team wasn't even a team. It was like a team of teams because they combined their solutions and they designed a sort of a multi-expert based recommender that actually, yes, it like overperformed compared to what Netflix had in production. But it was so complex that Netflix said, "Yeah, nice solution. Here is your prize, but we will deploy something simpler." So yeah, the work of data scientists and engineers should always be joint work, and they always need to coordinate what's physically possible, what kind of physical requirements exist, and so on.
Yeah, so you're talking kind of the the contradiction between will running 200 miles an hour into reality.
Yeah.
Steve, on your side, when you're talking with AI leaders about this demo to production gap, which Andrei demonstrated so beautifully right now, what's killing the business momentum after those initial wins, in your opinion?
Yeah, thanks, Aral. This is an important topic, absolutely crucial, because we're seeing a lot of interesting projects, prototypes, that works perfectly in a demo environment, and then once they are productionized, the problems start. Like one important factor that I'm seeing, for example, would be the pipeline to the data. Like think about in the real environment, the data changes. The let's say the buyers will have different reaction that you might expect. Although you have a lot of great curated data sets, nobody would have expected, as an example of like one of the old examples, if during pandemic, people buying toilet papers in Australia. So that was totally unexpected. But there are lots of different sort of behaviors that you will see in the real time from fresh data edge cases that needs a proper pipeline, needs a proper understanding of what's happening in the model, in the real environment. And also there are many other reasons. Like this is one of the big ones, but there's another one that I would just come to my mind is about the ROI. Many cases you would have these POCs and MVPs that look great, it's interesting, but then understanding how it would impact the whole the business, and how to understand the ROI and how to measure them, and it even add value based on the complexity. Is it a real use case that the companies need to focus on? At the end of the day, most of AI projects, when they are in the production environment, they are not cheap to maintain. So they need to understand exactly how they are driving value. And in many cases, they might start well, and then executives would lose the patience because they don't understand exactly how it is impacting and what are those milestones and special, I guess, deliverables that they're getting from these use cases. These are the reality checks that will come later.
So this is really a rain of different a rain of different hails and problems that hits you. I can certainly recognize that very well. And you, Roman, you've probably seen this a dozen times. What's the main thing research teams keep missing that kills their chances of ever going live, if they do?
Yeah, I think one of the main factors is one unified infrastructure where you can deploy your research there. And by doing this, you will comply with conventions and standards, and some requirements should be respected. And through this unified platform, you can also easily expose your research to real world POCs. And generally, this is our concept. And for example, if we're talking about AI security, so we have a lot of defenses. So each new approach, each new defense, each new research should be deployed to this unified platform. And then by this, we at least will verify we can call it like maturity or production readiness of this research. Similarly to, I said, defenses, but attacks as well. Like if we're developing a new attack, everything should be collected in one platform where we always have different types of maturity, attacks or defenses, but we have quite good understanding. All the platform already performed few POCs with different companies. So gradually, all the research that were deployed there will be much more matured as well, and we'll find a lot of gaps like this.
Okay, thank you very much. We're going to touch on this point later on different applications and creating different pipelines. You also touched on that right now, Steve. So heading to another direction, I see many companies spending millions building custom MLOps platforms that are worse than existing solutions. Teams often waste massive resources reinventing the wheel again and again and again, instead of focusing on AI innovation that actually drives business value. Heading back to you, Steve, when, in your opinion, should organizations stop building custom infrastructure and start buying platforms? What's the decision framework you're seeing to be working best in this field?
I see this a lot too, Harel. I mean, it's like a lot of times companies try to reinvent the wheel. There are lots of great platforms out there, and not just the MLOps, like in AI generally. There are lots of great tools and platforms out there that can bring competitive advantage, and companies can actually plug in, use, and go fast and create new opportunities. But for some reasons, many might choose the wrong path. And here's like, for me, it's pretty simple. If that particular tool, in this case is infrastructure, but in many cases, if that particular tool brings any competitive advantage, then that might be something that you need to look at it in terms of building or developing or
buying.
Buying.
Yes.
But then at the same time, if the product is out there and you can use it, you can plug it in, and it is going to deliver the value that you're expecting, then definitely it's an easy conversation about buying it. If you need to build on top of that in order to get extra advantage in the market, if that's the case, if it is not solving your problem, then think about doing it. I would usually, for my own company, whenever a team wants to do the same, reinventing the wheel, it was like, there's a product out there, but it doesn't have like one little feature that is neglectable, and let's bring together a couple of $100,000 as a budget to do it. My answer is always very, very straight. No, that's not going to be the focus. There's always better solutions than just putting all the efforts in something that might not be the focus of the company, and losing the momentum.
Gotcha. And Andriy, in another aspect of the same issue, what is the hidden cost component of the build everything internal approach that many companies or most companies miss in their calculations, in your opinion?
Well, it's not really hidden. It's very, very visible, because you you pay the salary of engineers, you pay for the hardware and so on. So the problem here is that even if you think that you are ahead of everyone else and there are no tools that you can use, so you need to build them from scratch, well, eventually you will not be ahead everyone else, because if it's it's a lucrative business directions, other players will go there. So eventually there will be a solution where the industry is the industry agreed on. It might be open source, might be cloud, whatever, and you will be maintaining your build here solution just for this, because you will say, okay, we already spent so much time building it, and it's really working the way we want, so we will continue maintaining it. So basically the market will save. They will all agree on something cheap and working just out of the box, and you will be like a hostage of your initial investment. So I think the question here, like, do you really consider yourself, like a trailblazer, and you really cannot find anything that would work for you, or you fool yourself and you are just wasting your time. As Steve said, like, if it's not your core business, then probably it's better to outsource. Of course, there are exceptions from every rule. Like, for example, Amazon, when they needed to build such a huge cloud infrastructure, well, it wasn't called cloud at the time, so they just needed a scalable distributed infrastructure, and there were none. And they built it from scratch, and then they saw that, wow, okay, we can even make a business out of it. Well, if you feel
Yes.
like you are as confident and lucky as Amazon was at the time, you can, of course, invest in building something yourself, and even probably later sell it. But most of the time, yeah, it's better to look where the market is heading and be, like, it's always better to be the second after the trailblazer, because they will assume most of the costs, and you will just follow in their way and benefit from what the community has built, what the market has built, and so on.
Okay, so thank you very much. So that's another angle on kind of Steve's position, the comparative advantage of one way to another, and discover whether it is within your focus or you're missing something in your calculation in this regard. And I'll head now back to the industry. Roman, how did Fujitsu approach this build versus buy, or how does it approach this build versus buy decision when evaluating AI infrastructure options?
Yeah, so I can answer only, from my side, from the researcher's side, because, we are quite a big global company. But from the research perspective, we are currently in really fast evolving domain, like generative AI. Everything changes so fast, and we clearly understood that this is not in our core, and we always trying to close the gap from the research perspective.
Got it.
And we have enough tasks and projects there, so we just have not enough resources to spend on creating our own AI infrastructure.
So
This is generally my thoughts.
got it. So if I can summarize all three positions here, is very much an issue of the focus of the company. And if you're orthogonal to the focus of the company with building your own stuff, either end to end or a practically very substantial part of it, then you're off focus. You're investing energy off focus. You're investing energy and time and money of your people in the wrong direction. I think that this is what comes through from what I'm hearing from all of you, which is very logical. Maybe let's address what kills more AI infrastructure projects than people usually realize: security requirements. Many AI platforms require you to send data to their infrastructure, which immediately disqualifies them for enterprise use cases. Teams get excited about a platform, a solution, a new thing, a new breakthrough, and then legal or security kills it, justifiably kills it because of data handling requirements. And I think, Roman, when you're assessing platforms for enterprise readiness, how do security requirements impact your infrastructure decisions?
Yeah, so generally the impact is huge. Since generally we are a Japanese company, and a lot of customers, they are governmental bodies, defense bodies, and it's a lot of sensitivity around the security issues. So it will be definitely a main factor if we will decide to go with some platform for us.
Mm-hmm.
Yes. So
Mm-hmm.
clearly, yeah, I agree that security is one of the main topics to assess when we decide to go with one of them.
So did you find yourself like heading into implementation or an exciting product or solution within your focus and crashed into a security issue based on the topics that I mentioned, since data should go out? And yeah.
Yeah, so it's sometimes on the on the managerial level that some projects we just decided not to continue with them because of the sensitivity or the location of the data, and so these issues are like on we're discussing this daily. So yeah, from our side, it's really important. And generally, as a researchers, I think security is not the main point. I mean, like infrastructure security, it's not the main issue or not the main point. And sometimes they're just doing mistakes by if they will define by themselves the infrastructure and deal with the security issues, probably they will do some mistakes. And there are some cases when we already did such things, and this usually will introduce some noise and distraction, because some alerts that will be raised and we need to address. So we prefer not to deal with this sometimes. This is where sometimes we'll actually, as you said, like we will avoid some projects if it's too secure.
Yeah, just avoid it. And Steve, how often do you see security concerns kill AI infrastructure projects after teams have been already excited about their capabilities?
Yeah, it's more than you want, because essentially I'm a technologist and I would like to see a lot more projects from POC to production. And um, CTOs, CIOs are super scared in many cases that security is one of their major concerns. I would say even, I think it was a recent report that shows like security is probably a number one concern when they are rejecting or canceling a project, even more than the quality of the model or the sort of the quality of the application, uh, because it's a do or die for enterprises. And in different industries are different, right? We're probably seeing some industries having less security as their major issue, but then as you get more regulated, it might actually not, it might even stop you from just even thinking about a project at all, because it doesn't worth it. It doesn't worth going through all the steps, right? The
Gotcha.
reality is like data is super important for everyone, for all the industries, all the applications. And in the regulated industries like finance, healthcare, government, it's even like a sort of the most important factor, how it is handled, how it's being stored and being securely communicated across different platforms, and especially in the pipelines. Um,
Got it.
I think that the quick answer is just um, in these industries, security is the first step. It's security by design as a first step, looking at every bit that is going to be productionized. It's going to be available, especially in the public sphere. And yeah, I mean, um, I would say to my colleagues in the technology side, instead of asking yourself, is this project is going to help the company? Ask yourself, is this project after getting security approval is going to be used? And that's very important bit, because if there is no way to go through that compliance, I would not even think about it at
Not
all.
even started.
Yeah,
Got it.
just let's save the time for everyone.
Andre, what should organizations look for in AI platforms? Like specifically, if they have strict security requirements of the types of industries that Steve just mentioned, what architecture actually works? Um, what's kind of the defining line there?
Well, I think well, first of all, just to add to the discussion, so the points Steve and Roman raised, I think there is also a human factor. So top managers don't like to be in a position where something fails, and they might be accused of not thinking, as a top manager, about infrastructure cost and so on. So basically, your project might be killed by the top management just because they are not sure that it's secure enough. So maybe it will your project, it's a revolution, and they will transform the business. But in the case of failure, who will be blamed? Not the engineer. It's the top manager who will be blamed. So I think top managers look for platforms where they might say in the end, in the case of a failure, and failures are quite frequent in AI and data science projects. So like from the very beginning, who will be blamed? And if they used some made out of glue and sticks solution, the company will say, where have you looked at? You saw from the very beginning that it wasn't built on the right ground. So from this perspective, yeah. So if there is a sensitive data, or if there is something business critical, the platform on which it will be built and especially ran in production should be somehow certified as secure. So just from this, human factor perspective, most large organizations will not move their data anywhere unless it's signed like certified ISO or some security some business like industry standards security certification. So
Yeah,
yeah,
SOC
so
2, HIPAA. Yeah.
Yeah, so it's
sorry, please.
in many cases it's not really like the security per se, but the perception of how well the project was organized.
Gotcha. So if I mold all of your answers together, what I feel is that security is not even accepted as a necessary evil in any configuration. Lack of security, in other words, lack of security, unacceptable, period. And the most secure thing is probably not risk security. So if security risks come up when data is moved from within to without the organization in order to use some sort of model, service, whatever it is, there's a risk. And if there's a risk, I don't want it and put it off the table. So the only thing that I will actually consider as an AI professional or an enterprise employing AI professionals, put it inside, leave it inside, don't let it out. That's it, period. And otherwise, let's go play in another playground. So kind of molding the things that I'm hearing from you guys, which is of course very, very, very reasonable. Okay, so as organizations grow, they end up with infrastructure spread everywhere. Some on-premise GPUs, some AWS, GCP, some Azure, different APIs, different billing models, different security configurations, yada, yada, yada. I can go on forever. And teams end up building custom orchestration layers just to use their own hardware efficiently. So back to you, Andriy. Why do most platforms lock you into a specific environment when organizations clearly need hybrid flexibility corresponding to the hybrid location of their compute?
Oh, well, it's a great question. Well, there is a commercial interest in locking your customers in so that they cannot easily leave. But there is also a question of providing a guarantee for your services. So if you control the environment in which your clients remain all the time, then you can sign quite restricting service agreements where you guarantee 99.8 SLA and so on. But you so certainly remember it was probably 15 years ago. My God, I'm getting old. Where they have started speaking in the enterprise about bring your own bring your own device, because previously when you came to the office there was this computer assigned to you, and like in the 80s, 90s, thousands, maybe it was okay, but then people really started to see the divergence between what they can use at home. And it was after iPhone, the first iPhone, and then iPad, and touch screen, and Wi-Fi, and Bluetooth, everything. And then they come to the office, and it's a computer from 15 years ago, and they just feel like they work with in the conditions of their grandparents. So like employees started to demand, okay, let me work on my computer when I'm in the office. And it was this initial wave of excitement about bring your own device. Like, okay, you can just bring your device. We install some secure environment on it, and it works. But in the end, the security administrators and system administrators started to complain because it has become a zoo. Impossible to actually guarantee anything. One device, when connects, blocks everyone else, and so on. So finally, again, there was a divergence, and then it was a convergence. And now the employer provides you a device that they can kind of certify. They install some environment for you, and so on. And you can bring this device back home if you want. So it's the same about enterprise infrastructure when you work with data and compute and so on. If you give too much flexibility to your customers, eventually some customer will consume the resources of everyone else, or they will break the system, or they will bring some viruses and so on. So this is why providers try to keep their clients in some sandbox that they control.
Got you. Understood. And Steve, what friction are you hearing about when teams try to use resources across different environments?
I mean, obviously, you mentioned some of them. I'm going to dig deeper in there, but I have seen many enterprises that for some reason they built a spaghetti of different tech solutions that not necessarily need to be used in the same environment. Like they want to plug into as many random apps and infrastructures and clouds and platforms as possible. And in some cases, they need to put too much effort to actually make that technology work together, like the orchestration layer that needs to be built. As you mentioned, like in some cases, a custom orchestration that needs to be maintained, built, and like just think about the technology side of it, the difficulty, the maintenance, and at the same time, the the context switch. There are going to be a lot of technical leaders that needs to always be on top of everything that is happening. So this is one of the big pain points that I'm seeing across the board. And then subsequently, because of having that many complex technologies intertwined, then predicting exactly what sources they need, how to tap into it, what are the costs, the prediction, and sort of the architecture in order to expand the project, or maybe in some cases they need to save some costs. It's just so difficult to make it work. And then the previous question, back to the security, right? So it will then again go back to some of the more touch points, the more complex environment that you have, the more point of failure you're building, and the
Yeah.
more
Yes.
complexity the maintenance of the security. So
Clearly.
these are all frictions for not only the technical team, which they are going to sweat like bullets, when things go wrong. Also for the management team, as Andriy just mentioned, because they, at the end of the day, they need to answer if something goes wrong, and they would have more, their neck on on the block.
Got it. Yeah, yeah, well, right. You're right. I think that escalates very much when we're talking about infrastructure that serves numerous models for AI, and then the numerous weaknesses actually escalate the impact. Roman, Fujitsu obviously has complex infrastructure requirements. When you evaluated Swarm One, how important is it that the platform can actually work with multiple environments, on-prem, cloud, hybrid, without forcing you to rebuild everything every time?
Yeah, I think for us, the flexibility as a researchers, the flexibility is one of the important factors because like imagine, so we both building and developing new solutions, but we're also publishing research papers, and there are benchmarks and different models that we should get access to and run all the experiments with these models. It doesn't matter if we have the option to get this model from Azure Cloud or AWS, everything should be available for us. And if we want to perform some additional evaluations with internal data, then we need to use our internal clusters for this. So the flexibility for us as researchers is one of the main important things that we are looking in such a platform. So I think there is no other way to actually publish research papers since without comparing everything to known benchmarks, different models, you will just not able publish. Yeah,
got it. So essentially, if I kind of summarize what I hear is that for you, the both from the security point of view, as well as from the operability point of view, as well as from the teamwork point of view, the ability of infrastructure to operate in different configurations of on-prem, on cloud, or hybrid is a material consideration, which of course makes a lot of sense. And as AI workloads continue evolving with new model architectures, different data types, varying compute environments, the infrastructure challenge isn't getting easier. It is in fact getting more and more and more complex. Teams need platforms to get that get smarter automatically, not platforms that require teams to become infrastructure experts in every new domain. And may I say, infrastructure slaves in every new AI domain. Roman, back to you. What advice would you give other research leaders who are assessing AI infrastructure platforms in this regard?
So definitely you don't want to spend your limited resources to manage this AI infrastructure. So first advice is, again, find something that will improve and allow you not to deal with this by daily. And we have some specifics here also related to research papers. If you want to publish, sometimes you have some short time for rebuttaling of the paper. So it's come back to you with some comments that you need to improve and perform more experiments. And then you have only a few days to respond to a committee. And then maybe if you can't fastly adjust the infrastructure and perform additional experiments, it's just a matter if your paper will be accepted and published, or it will just miss the deadline. So for us, flexible infrastructure is, as I said previously, is one of the points to check and verify. And again, if in the current environment, we just have shortages of the good researchers in the domain of generative AI, and I don't want to spend their time on infrastructure configuration. It's just, it's impossible.
I think, thank you for that. I think that this actually voices a very stark issue that permeates industries without regard to their vertical. The ability to actually address problems as quick as possible using the talent, which is very rare these days, on infrastructure is just spending brain and money on for nothing. So I think that this is a huge consideration. Andrei, as these workloads keep evolving, how should infrastructure platforms adapt, in your opinion, without requiring manual reconfiguration for every new approach of the sort that Roman just pointed at?
Well, the problems keep well. I mean, the kind of obstacles we face, and when I say we, I mean data scientists, we face are changing. You're right, but I think what is not changing is our brain, and our brain isn't wired well for thinking in parallel processing and in probabilities. So people always are confused by chances. And if you ask some person to think about multiple processes at the same time, they will quickly lose their track. It's like jungling the different objects. So it's really hard to control all of them. So I think from this perspective, what's important for companies is to kind of shield their people from this kind of thinking. Like, I don't want to think about how many computers I run in parallel to solve my problem. I don't want to think about what are the chances that this event will affect that event. So like the happiest time, I think, for data scientists was when they could pip install scikit-learn and then open a notebook and type from sklearn import lr, and that's it. So now the times are different, but this is what people keep asking for. Give me an environment in which I can think about my business problem, and I can make an abstraction of the infrastructure, because thinking in terms of like GPUs, or how many tokens you can fit into a GPU memory, or how can you orchestrate multiple GPUs so that when the first one finishes processing the first layer, the second one is able to continue with the second layer. Scientists and just people in general don't want to think in terms of this concept. So yeah, the company should think about shielding them from this.
Got you. This reminds me very much about the discussions around 1994, 1995, with the presentation, with the movement into 64-bit, and quite similar considerations were taking place then. Steve, in your opinion, what should AI leaders prioritize when choosing infrastructure for the next phase of AI development? What's the key differentiator in your opinion? What's the key preparation?
I think this is something that I 100% agree with Andrei here. Adaptability and sort of covering those complexities by certain abstractions is the best for technologists to take care of things that they actually need to focus on. And there are many, many examples that we are seeing that this is happening as a sort of any technology matures. And even ChatGPT recently just put an abstraction over all their models, and it's like, okay, now you have one choice. We will take care of it. We will choose for you what is the best way to answer your question. And I remember back then, old days, Andrei just mentioned, reminds me of the time that we were playing with TensorFlow, and it was pretty complex to build a proper neural network with all the hyperparameters and parameters. But then, the PyTorch and AutoML, they came in and they helped a lot in many cases. I feel this is the exact maturity that the infrastructure, the DevOps, MLOps, and when a company wants to decide whether to go with A or B, they will think about this adaptability and intelligence and the smartness into the platform. So then their resources, which is going to be very expensive, obviously, they would focus on something that would drive the company rather than taking care of the logistics and complexity of the nitty gritty of the setting up the environment than to build a real value.
Yeah, this is absolutely correct. I think, I was reviewing industry data showing that AI teams spend sometimes 60, 70, 80% of their time on infrastructure, from basic setup like YAML files and Docker configs to the endless trial and error of guessing optimal GPU types, which, by the way, touches on what you said earlier, Andrei. The batch sizes and configurations, strategies, and so on and so forth. In some cases, companies are paying literally hundreds of thousands, if not millions of dollars for a data scientist to gain the proficiency in infrastructure, which is, of course, not data science, instead of AI innovation. Roman, at Fujitsu Research, do you measure how much researcher time gets spent on infrastructure setup?
Yeah, so we don't have any direct measurements, but I can say you that constantly we have people who considering them as like subscription or resource group owners, and they constantly spending at least like 15-20% of their time, to just maintain it and perform some usual tasks there. And when we will start some complex new project, probably it will be increased even more. But I also want to say you that it's a point of like morale, and it's also reduced onboarding time if you have not really complex environment. So if we will have a new researcher, so probably onboarding time will be much lower. And if you will have complex environment, first you need to maintain it, and then if you want to onboard a new team member, it will be much more complicated as well. So yeah, I think it's like to measure the time we're spending, but also a morale of the team, to maintain it, and generally the onboarding time of new team members as well.
You actually lit up, I think, a very, very important part, because these people, these experts, are human beings. Eventually, they do not want themselves to be crashing against proficiencies that they have nothing to do with. It. They are not their central focus. And in that area where they're supposed to actually go through hell and back in order to put something to work, and especially in the environment that you spoke about earlier, when things have to happen quickly, as they always do, then that takes a material toll on their morale and their ability to, and their willingness and their I would say passion to work as teams. So making a very strong point here. By the way, I've never heard it before, and I think that it has a really, really substantial significance. And maybe last, with Swarm One, what did you discover about this time allocation problem when you used the platform?
Yeah, so when we used it, first of all, I think we started to examine the platform from the cost perspective, and we saw quite high improvement and lower cost, around 60%, in the experiments and the POC that we did. And also, generally, it took us between twice to 4 times faster to accomplish, the experiments that we need for our research. At least the experiments that we defined, and we defined 2 types of experiments. Some, let's call it batch inference of different models, and also some training of models, because these are the 2 types of tasks that we're usually performing.
Yeah.
And as I said, in both of them, we saw quite high improvement from the perspective of costs and time.
So actually, this draws a direct line between cost and time and idle time and company morale and team morale. So as I said, this lit a very interesting point from my point of view. Thank you for bringing this to all of ours attention. I'm sure that our audience is not less excited about it. Um, so, in a sense, to summarize, okay, we'll now move to the Q&A session. And just before that, we want to give you a special offer that will keep you, your AI team, and your company to avoid these infrastructure traps once and for all. If you're ready to explore what autonomous AI infrastructure could mean for your organization, click the link in the chat. Let me just put it in the chat. Now it's in the chat. Or scan the barcode, which I'll put out on in a moment, to get a demo and some hefty compute to go with it. Please do stay with us for a minute until the Q&A session begins. Please don't go away. I feel like I'm a newsman or something. So please do not go away because the QA session is just about to begin. Just a second. And our experts, please stay with us, of course. So I hope you see our slide here. We'll let it run for a few seconds so you have time to take a picture of it or run it by your phone. And of course, I'll put it on after our Q&A session begins. Or ends, I'm sorry. Okay, I think that was enough. Let's do our Q&A. We'll now be answering your questions live with Swarm One CTO Ben, who's joined us. Unfortunately, we won't be able to get to everyone and everyone's questions right now, but we'll follow up with a webinar with anyone whose question wasn't addressed. So welcome, Ben.
Hi guys, I'm Ben, Swarm One CTO. Due to time constraints, I'll answer only 3 questions from the crowd. I'll start with the first one, asking about Swarm One supporting infrastructure type, different infrastructure types. So Swarm One can operate on any type of infrastructure you can think of. Could be on-prem, that means you can install Swarm One with one-click installation on your own machine, wherever it lies. And then also you can connect your own cloud. That means if the enterprise is working with AWS, Azure, GCP, you can connect Swarm One into your cloud, and then we'll also optimize training, evaluating, or deploy AI models on your infrastructure, your own on-prem infrastructure, and only if needed, we'll ramp up into your cloud. Everything is managed automatically. You don't have to manage any DevOps, MLOps, SecOps, anything. As for the second question, do we support AI inference? So yes, we are supporting deploying models. Again, could be on your on-prem infrastructure, could be on your own cloud. Also, while doing that, the same as for training and evaluation, we are doing the optimization automatically for you. We are choosing the right hardware, the right strategy to deploy or to train or to evaluate your workloads. As for inference specifically, we are utilizing some different optimization. We'll not get into that right now. We can talk about it later. But the most important fact is that we're doing what we call demand-aware optimization to your workloads. That means when there is rush hour and a lot of people are accessing to a model, or in times where there's, everyone else sleeping. So we are managing the entire infrastructure for that, if needed to deploy more nodes, if needed to utilize some different optimizations to support the SLA that you want for your inference, for your deployment. So that's on that side. In terms of how Swarm One eliminate idle time, so Swarm One eliminate idle time by allowing data scientists, AI engineers, and also any engineer to train, evaluate, and deploy AI models from its own environment with 2 lines of code, without talking to anyone, without DevOps, MLOps, SecOps, without anything. Then automatically the platform decides where to deploy, how to execute your workload, and with which infrastructure to use. So even if you have some V100s left in your on-prem data center, you can still utilize them. We'll make sure that your workload will run over there. And if needed, we'll go to the cloud. Then Swarm One also optimized during runtime, as I said, for inference, but same for training and evaluation, the workload execution, utilizing different strategies, different methods, utilizing the machine in the best way, and optimizing the data pipelines without any DevOps, MLOps, SecOps, eliminating that entire stack and just allowing your AI engineers focus on what is the most important task, which is deploying AI models. Thank you.
Well, thank you very much, Ben. So I want to give a huge thanks to our incredible guests, Steve Nouri, for sharing those real great insights. Thank you, Steve. And Andriy Burkov for the technical depth and incredible expertise. And thank you, Andriy. And very much to Roman Vainshtein for bringing that authentic enterprise perspective from Fujitsu research. This was exactly the kind of honest, practical, to the point, focused discussion our community needs. And there are going to be many more, I must say. So thank you all for joining us today. Thank you, our experts. And the question isn't whether AI infrastructure will become autonomous. It's only how quickly your team will make that transition. Love you all. See you again soon. Take care.
Thank you.
Thank you.
Thank you.